This question is a WAEC mathematics past question. It is an indicial equation involving fraction. We can decide to break down these powers before applying some basic rules of indices, or we can skip the breaking down of the powers and just go straight into applying these basic laws of indices. Three of the basic rules that we are going to apply from indices are: when we have a raised to power m times a raised to power n, the law says that we can simply write one of them and add up the powers like this. That is, if we have multiplication in between them. So we have addition here. So that's the first principle that we are going to apply. The second principle says that if we have a raised to power m divided by a raised to power n, similar to the first principle, this is going to be a raised to power m minus n. This is because we have division here, so this has to be subtraction here. And the third principle says that if we have a raised to power m is equal to a raised to power n, it implies that m is equal to n, simply because of the fact that the bases are the same. So if the bases are the same, then the powers must be the same. So the question 3 raised to power 2x plus 1 divided by 3 raised to power 3x minus 4 times 3 raised to power 6 minus 7x is equal to 27 raised to power x can be solved by simply starting with the denominator here. This denominator can be written as 3 raised to power 3x minus 4, then plus 6 minus 7x according to the first rule here. And then the numerator, which is 3 raised to power 2x plus 1, will be written as it is equal to. So we can break down 27 to give us 3 raised to power 3. And then because we already have x here, this is going to be 3 raised to power 3x. So this means that the right hand side is now 3 raised to power 3x. Let's tidy up this denominator. So this gives us 3 raised to power 2x plus 1 divided by 3 raised to power, this is 3x minus 7x, that's negative 4x. So we have 3 raised to power negative 4x. Then we have minus 4 plus 6 here, which is simply going to give us 2. So we have plus 2 is equal to 3 raised to power 3x. And I'm going to put that back into the bracket like this because of the next principle that I'm going to apply. So applying the second principle I wrote earlier, this is now going to be 3 raised to power 2x plus 1 minus negative 4x plus 2 is equal to 3 raised to power 3x. If we tidy up the left hand side, we are going to have 3, open up the bracket, 2x plus 1, minus times minus is plus, so we have 4x, minus times plus is negative, we have minus 2 is equal to 3 raised to power 3x. Still tidying this up, we now have 3 raised to power, this is 2x, this is 4x, so altogether that is 6x. And then this is plus 1, and this is minus 2. Plus 1 minus 2 is simply minus 1. So that is equal to 3 raised to power 3x. And then finally, we apply the last principle, which says that if the bases are the same, then we can go ahead and simply equate their powers. That is 6x minus 1 is now equal to 3x. So we say 6x minus 1 is equal to 3x. We solve for x by bringing all the unknown to the left hand side and the term without the unknown to the right hand side. So we are simply going to have 6x minus 3x on the left hand side, and then we take 1 to the right hand side. So we have 3x. 6x minus 3x is 3x, then is equal to 1. Go ahead and divide through by 3. Divide through by 3, so that your final answer, as this takes care of this, is x is equal to 1 over 3. As cumbersome as that question looks, the final answer is simply 1 over 3. If you have enjoyed this video, kindly give it a thumbs up. Remember to subscribe to my channel if you are yet to do so, and I'll see you in my next video.